Here we have this function f of x equal to x cube minus 2y, absolute value of x cube plus 1. We have to find the horizontal asymptotes. Right. This function, there's an absolute function here. Otherwise, it's a rational function. So this function is actually, we can write it as two different functions. When x is greater than 0, this becomes plus x. And when x is, that is x cube. And when x is less than 0, this becomes minus x cube. Basically, it is a combination of two different functions. Now, when there are two different functions, what exactly are those horizontal asymptotes? Okay, so let us try to write like this: x cube by here when x is tending to 0. That means when x is positive, then we can write this as absolute value of x cube as x cube. Right. And we earlier discussed, then this is a rational function. What is the rational function? Ratio, it's a ratio of p of x by q of x. Both are polynomials. Right. And here both the degrees are same. Obviously, then what is the horizontal asymptote? It is the ratio of these coefficients 1 by 1, right? We discussed that when both the powers are same, both the highest powers are same of both p of x and q of x, then the ratio of the coefficients is is the horizontal asymptote. For example, if it is in the form of x squared by x power 4, when the denominator, the coefficient of highest power in the denominator is greater than the numerator, then y-axis, x-axis is the asymptote, right? When both the powers are equal, then the ratio of the coefficients, right, of the highest powers, when the denominator has the highest, when denominator power of the denominator, highest power of the denominator is higher than the highest power of denominator, then x-axis is an asymptote, right? Now, when x is less than 0, this equation turns out to be minus x cube, right? Absolute value of x is minus x cube. Then what is that? Then 1 by minus 1. So these two are the horizontal asymptotes. Okay, we earlier also discussed what is an horizontal asymptote. That means a line, whatever, this should be a horizontal line first of all, right? And it's an horizontal asymptote if either of this, when x tends to infinity, f of x is equal to b, limit x tends to infinity, f of x, right? What does that mean? This f of x should approach this line b, right, as close as we want. If this is the line y equal to b, f of x should approach either from this side or from this side, whatever. And beyond a point, the distance between, let's say, if we define some limit, okay, if we define some limit, then let's say some epsilon that we have defined, plus or minus epsilon of b plus epsilon and b minus epsilon, let's say. Then beyond a point of, let's say, x naught, right? The entire graph should lie between epsilon, b plus epsilon and b minus epsilon, right? The entire graph should lie between for whatever epsilon that we are defining. That is this limit. What does that mean? F of x should get as close to y equal to b as we want. That means if whatever epsilon that we are defining, b plus epsilon and b minus epsilon, what does that mean? We are drawing two lines above and below this y equal to b, this horizontal line. Now, whatever graph that we are talking about, this graph should lie between these two lines beyond some x naught, whatever x naught, right? That graph should always lie beyond this x naught. If you are going right, it should always lie between these two lines. For whatever epsilon can be 0, 0, epsilon can be 0 0.1, 0 0.01, whatever epsilon that we are defining. Epsilon is in a positive quantity, right? That is a horizontal asymptote. Basically, informally, if you want to say, then horizontal asymptote is that line to which this graph approaches as close as we want. That is informal way of saying this. Now, this function, whatever this function is given, when x is greater than 0, we have this y equal to 1. When x is less than 0, we have this y equal to minus 1. So basically, how does this graph look? A graph looks something like this. And this one, it approaches as x approaches infinity. It is approaching this line y equal to 1. And x is approaching minus infinity. It is approaching this line y equal to minus 1. Right, guys? Hope you like this. Thank you.